Right, this is the old Edexcel specification from January 2013, old M2 question. It looks like a variable acceleration question. We've got the velocity in terms of t here as a vector, but you can actually do it as a SUVAT because if you differentiate the velocity, you will actually get a constant vector, but I'll show you do that in a moment. So we've got to find the value t when the velocity is parallel to the vector j, so it's going to have no I component. And then we find an expression for the position vector after time t seconds, and then we get this other question at the end. Right, so a little bit about what's going on. It starts off at the position vector with 2i plus 5j, so 2 at the right and 5 up. The velocity as a column vector looks like this. When t is 0, it's going to be minus 5 and 3, so it's going sort of up to the left. And then when t is 1, velocity is minus 1 and 3. Which looks like this, and then when t is 2, the velocity is 3, 3. So it's going up to the right. When t is 3, 7, 3. So it's moving like this. So I'm going to put it here, and I'm actually going to find out what this is. This is in terms of t. But so the first part of the question: find the value of t when the velocity is parallel to the vector j. So it's going straight up, really, so it's about here. It's going to be moving vertically. So this is the velocity. So if it's moving vertically, it's got no I component, so I just put 4t minus 5 equals 0, given t is 5 over 4. That's 1 mark. Then find the expression for the position vector. This position vector at time t seconds, or the general one. Well, I need to integrate the velocity vector, so that's going to be 2t squared minus 5t, but I need to put a plus c on the end. I don't need one down here, so I'm going to put a plus c1 on the top. And then when I integrate the j component, it's just 3t plus c2. It tells me when t is 0, the position vector is 2i plus 5j, so I can write t is 0, the position vector is 2, 5. So if t is 0, all these terms are 0. So the c1 is going to be 2 and the c2 is going to be 5. So that's what the position vector is at any particular time. Like I say, we can also do it as a SUVAT, because if this is the velocity vector, if I differentiate this to get the acceleration vector, that's just going to be 4 and 0, and that's just constant. No t's in there. So I can use a SUVAT to find the position vector. I'm going to use this one, but I'm going to use the sort of the vector form. But I need to know the u, the initial velocity when t was 0. I always had before, actually. It was minus 5, 3, putting t is 0 into here. So then this in sort of the vector form looks like this. So the position, the displacement vector, so the initial velocity vector times the time and a half times the acceleration vector times t squared. So the position vector, that position vector RP, the u is minus 5, 3 times by the t plus a half times the acceleration vector times t squared. But that's this vector, that's the displacement, because it starts there, ends up there after t seconds. So to get the position vector RP, I need to add this one on, which is just the initial, where it is initially. And then I get what I had before, because I've actually got 2t squared here, minus 5t and 2 on the top, and on the bottom I've just got 3t, nothing there, and 5. Right, and the last part, second particle q moves with constant velocity minus 2 plus cj. When t is 0, the position vector is 11i plus 2j. So it's down here to start off with. So if I'm going to want the position vector sort of in terms of t. So that's where it starts, but it's got constant velocity. So it starts there, and then after a second, it's going to be here. After 2 seconds, it's going to be there. So if I want to know where it is after t seconds, and to find the position vector of q, I'm just going to multiply the velocity vector by t and add that on to the initial position vector. And it says the particles P collide, so the position vector is going to be the same at the point with position vector di plus 14j. So they're going to be to d14. I'll put them all equal to each other. There's the RP, there's the RQ, as one column vector, and then the D14. Got lots of things I can solve here. I need to find out what C and D are. I could maybe solve these two equal to each other. I've got a quadratic then. I think what I'm going to do, 3t plus 5 equals 14. That looks much easier. That gives me t is equal to 3. But I want the C and the D though. This 2 plus ct equals 14. I'll give you the C, because I know that t is equal to 3. So that gives me C is equal to 4. And then finally, to get the D, I'll put it into this one. But I think 11 minus 2t is probably easier. And that gives me t is equal to 5.